Java Review Conditionals. While algorithms can get extremely complex and seem to give computers a mind of their own, every decision made comes down to a choice between two things: true or false, yes or no, on or off, 0 or 1. In other words, at its most basic level, a computer is only a binary machine, a system working entirely based upon two potential outcomes. Comparisons must be made in programming for a variety of reasons. Computers must be able to make decisions, and this is done by comparing sets of data and making a selection as to which option will be executed. Computers must be able to repeatedly execute a set of commands and can do so by comparing data. Within comparison or Boolean expression, we see the practice of selection being used. Without comparisons, computer programming as we know it would not be able to function. Unfortunately, all algorithms are not straightforward. There will come a time where a decision or choice must be made. Selection is when an algorithm follows one of two paths based on whether a condition is true or false. The flowchart below shows selection. So we start, then there's a condition. If the condition is true, we go this way. If the condition is false, we go this way. Conditions appear in the form of what is called an if-else statement. If blank is true, then follow the true procedure, else follow the false procedure. Let's look at an example. We set x equal to 10. Then we ask the question, is x greater than 5? Since 10 is greater than 5, we follow the true line and we print x is greater than 5. Now let's make a small change. In this program, all we've changed is this 10 becomes a 0. So we set x equal to 0. Then we ask that same question, is x greater than 5? Since 0 is not greater than 5, we follow the false line and nothing prints out. If the condition was false, nothing printed out. Selection allows us to create an alternate path when this happens as well. For example, in this case, the program could output x is not greater than 5 if the condition is false. So here, it's either going to print x is greater than 5 or x is not greater than 5, depending on the value of x. Relational operators are used to compare values in both Java and Praxis code. We have less than or equal to, greater than or equal to, and not equal. These operators are used mostly as conditions within loops or conditional expressions, which we will learn about soon. The result of evaluating a condition where a relational operator is used is Boolean type. If the comparison is true, it will equal true. Otherwise, it will equal false. If x is set to 5, x is greater than or equal to 10 will return false. An equal sign in math shows equality, but depending on the context, in computer programming, it could have different meanings. It could either be assigning a value to a variable, or if it exists in a pair, comparing values. One equal sign is an assignment operator, which assigns a value to a variable. When comparing values or testing for equality, like is x equal to y, we will use the relational operator, which is two equal signs. Here are some more examples. What will print out for each example? Alright, so for the first example, x is 2, y is 2. Print x is equal to y. So x and y do have the same value, therefore the output will be true. A is 3, b is 1. Print b is greater than or equal to a. 1 is greater than or equal to 3 is not true. That is false. So this will print false. D is 2, E is 4. So D is 2, E is 4. 2 is not equal to 4 is a true statement. So this will print true. Logical operators, sometimes called Boolean operators, are used to return a Boolean result that will evaluate true or false. So in Java, we have the double ampersand, and that means and. So x is greater than 3 and x is less than 5. we have the 2 lines, which means or, so this would be x is less than 3 or x is greater than 5. And then the exclamation mark means not. So not match, if match was true, then not match would be false. Logical operators or Boolean operators are necessary in Praxis code. Keywords such as and, or, and not are used to represent these functions, but they have the same meaning as the Java symbols. So instead of 2 ampersands, we have lowercase and. Instead of the 2 vertical lines, we have or. Instead of the exclamation mark, we have not. Here are some more examples. Boolean x is true. Print not x. Well, since x is true, not x is false. Boolean y is false. Print not y. Since y is false, not false is going to print true. Here's one more example. Print not 2 is less than 3 and 4 is greater than 2. This will print false. Let's think through the code together. Inside the inner parentheses, it says 2 is less than 3 and 4 is greater than 2. This is asking us, is 2 less than 3, and that is true, and is 4 greater than 2? That is also true. So since both of those statements are true, true and true will give us true for this whole parentheses here. So this is all true. However, there is a not symbol out front, therefore not true will give us false. Determine what will print out and why. Print 2 is less than 3 and 2 is greater than -3. Alright, so 2 is less than 3 is true. 2 is greater than -3 is true. True and true will print true. So yes, this will print true since 2 is less than 3 and 2 is greater than -3. So when you use the AND operator, both pieces must be true to print true. So the first conditional must be true and the second conditional must be true in order to print true. Relational and logical operators are very useful in if statements. Boolean expressions that make use of those 2 types of operators are essential for a conditional, such as an if statement to function correctly. The syntax of the if statement is if condition, then we have the body here. So curly braces are required before and after all statements. Parentheses are required around the condition, which is a logical or Boolean expression. The code above is saying if the condition is true, run the code inside of the curly braces. If the condition is not true, do not run the code inside of the curly braces. The overall function of an if statement is the same in Praxis code as it is in Java, but it looks slightly different. So here we have parentheses around the condition again, but now we have, instead of curly braces, we just have these indented statements where no semicolons are needed at the end of the statements, but you do need an end if statement in order to conclude the if statement. And this code is saying if the condition is true, run the code. If the condition is not true, do not run the code. The if statement will only execute if the condition is true. Below are 2 examples. Determine the output of each. Here's number 1. If 2 is greater than 1, print math rules. End if. Alright, so 2 is greater than 1, so this is true, so this will print math rules. If it is false, as in number 2, the statement will be completely passed over and ignored. So if 2 is less than 1, this is false, therefore the computer won't even read that line, and it will just keep going. It is generally considered poor programming practice to list back-to-back if statements for alternating cases. In order for programs to take the false result into consideration, an if-else statement is used. The syntax of the if-else statement is here. If condition, run statement 1, else, run statement 2, end if. If an if-else statement is executed, the program determines if the condition is true or false. If it is true, it will execute statement 1. If it is false, it will execute statement 2. What is the output of this code segment? Okay, so x is set to 5 if x is not equal to 8. Well, 5 is not equal to 8, so this is true. Therefore, we are going to run this line here and ignore the else statement. So it will print incorrect. But what if we initially set x equal to 8? If we set x equal to 8, then this conditional would be false. So therefore, we would skip this line and we would run the else portion here. Print correct. Sometimes there may be a need for two conditions to be met one after the other. For example, write a segment of code that outputs parking lot access to high school senior drivers who have parking passes. All students who are not seniors will be denied access, and all seniors who don't have a parking pass will also be denied access. In this scenario, let's first ask the question, is the driver a senior? If the answer to that question is no, then access is denied and the program is over. If the answer is yes, then we have a second question to ask. Does this senior have a parking pass? If the answer is no, access is denied, program is over. If the answer to the second question is also yes, they are allowed into the parking lot. So let's turn these ideas into code. Here is a sample solution. We declare two variables. One is senior, the other is pass. And these variables will hold either a y for yes or an n for no. So each student will have, either two y's, an n and an n, a y and an n, something like that. Then here's the code that checks these variables. If senior is set to no, or n, access is denied. Else, so this else will run if senior is set to y, and it will run this code. Then we have another if-else statement nested inside of this if-else statement. If pass is equal to y, then access is granted. Else, access denied. So this statement here will run if the student is a senior but does not have a pass. So remember, in Praxis code, we need these end-if statements at the end. So in this case, where the student is a senior and has a pass, access will be granted.